Okay, everyone, let's start. And welcome to the Edge Computing Association. Actually, it's our inaugural webinar as the Edge Computing Association. And today we're going to be talking about the next wave of computing, which we believe is the intelligent edge cloud. You know, what does this mean exactly, and how can IT respond to these changes? I'm Phil Bliss. I'm president of the ECA. I'm what I call a digital pioneer, which is what you call yourself when you get a fair amount of gray hair. I have built quite a number of products over the past decade or so. I have a national and international track record, and I've been a strategic advisor to many technology, education, not-for-profit, and actually American Indian companies. I'm not American Indian, as you can hear from my voice, but I have had the delight to work with some great people in that area. Vivek is joining us as Vivek's head of Digitalization and Blockchain Practice at Markets and Markets. He's a seasoned consulting and market development professional with over 12 years of experience. Vivek's especially interested in technology-enabled innovation and disruption, edge computing, the cloud, big data, analytics, blockchain, artificial intelligence, and the Internet of Things. And Tom Ward is the VP Marketing of Qnext. Tom's a 30-year veteran. He was a founding employee at ATI. He has an MBA from the Schulich School of Business, and really terrific experience in both large and multinational companies. He's a senior executive at Qnext with global extensive experience motivating and leading teams and successfully developing global and distribution channels. And Tom's going to be talking specifically about the FileFlex product, and FileFlex are our sponsors today. So without further ado, I am going to pass over to Vivek, who will dive in with his presentation.
Yeah, thanks, Philip, for the introduction. What I am going to do over next few minutes is actually talk about the current status of edge computing and related challenges. So let's get started by understanding what is edge computing. Fundamentally, edge computing is a distributed computing paradigm in which applications, data storage, and processing are placed at the edge of the network, depending upon how one defines the edge or what is considered as edge. Different concepts and varying architectures such as cloudlet, fog computing, mobile edge computing has evolved. The basic idea in all these approaches is to implement cloud computing capabilities in an IT service environment closer to the source of data, where we need to act upon the data. Take, for instance, ETSI's multi-access edge computing architecture. It is designed to implement edge servers at cellular base stations, creating a network of mesh micro data centers. Some people view edge computing as a concept which is opposed to the centralized cloud, which is the dominant architecture today. However, Markets and Markets' view is that edge computing is a natural evolution of the centralized cloud, as it helps really bridge some of the limitations of it. Cloud had been there from around 12 years now, and we believe that it will continue to drive the IT spending growth, at least in near term. Let's take a look what is really driving this shift or evolution, and why do I say that edge cloud is a natural evolution of centralized cloud. At the heart of this evolution of the architecture is confluence of technology innovation such as Internet of Things, 5G, edge artificial intelligence, augmented reality, virtual reality, which are creating a needs which cannot really be fulfilled by centralized computing architecture. Take, for instance, Internet of Things. with proliferation of connected devices and endpoints, already the amount of data that is being generated has exceeded the data center traffic. Cisco, in one of the studies, has actually estimated that all people, machine, and things connected will generate about 850 zettabytes of data per year by 2021. A lot of this data will be ephemeral in the sense that it will not really be needed to store and process this data. But even if we assume roughly about 10% of this as usable data, that itself is about 85 zettabytes, which is 4 times more than the expected data center traffic by 2021. Now, transporting all this usable data to a centralized cloud is actually impractical. Not only it will create network congestion, but also it will be cost inefficient. And it is here edge and fog computing is expected to bridge the gap by basically allowing for localized storage and processing of data. In fact, in present day world also, if we look at all the data stored, roughly about 84% of the data actually is stored on client devices or M2M modules, and only about 16% is actually stored in data centers. And this situation is not likely to change in near term as well. So apart from addressing the problem of network congestion, edge computing also enables superior application performance and quality of experience required by certain use cases driven by some of the technologies that I mentioned, whether it's augmented reality, virtual reality. Take, for instance, deep learning smart cameras, which will be used for emotional intelligence analysis or facial recognition, or autonomous cars, right, in the 5G area. All of these use cases or application areas will generate a lot of data which will need to be acted upon locally, closer to the source of data. In other words, all these use cases really need very low latency, which is less than 10 milliseconds, and very high bandwidth, more than 1 Gbps per second. And to achieve such low latency and high bandwidth is not really easy in a centralized cloud environment. And this is again another area where edge computing will bridge this gap or overcome the limitation of the centralized cloud computing architecture. And that's why I think it's fair to say edge computing will bridge that gap as well. And in that sense, it is a natural evolution of the centralized cloud computing architecture, what we have today. Let's move ahead. So now, based on these drivers, what we are seeing in the market is that edge computing is already becoming an enterprise priority. There are multiple studies that actually point towards this. There was a survey done last year by Network World, wherein roughly about 1/3 of people, respondents mentioned that they are in some stage of edge computing adoption. Either they are running some proof of concept or they are conducting limited trials, and another 1/3 respondents said that they are actively researching or exploring edge computing. Likewise, an estimate by IDC Canada basically suggested that roughly about 10% of Canadian enterprises last year were actually planning to pilot some new architecture of edge computing. And all these, at the moment, all these pilots and proof of concepts actually are driven more around media, which is basically video content delivery or AR, VR. AR/VR. And in our own assessment also, what we have found is that the global edge computing spend is likely to reach $6.73 billion by 2022, which is a growth rate of about 35% over 2017. And a lot of this spend actually is likely to be, on edge nodes and edge data centers or micro data centers, as well as the software applications and platforms such as IoT platforms being deployed in cloud. Having said that, so as organizations are looking to adopt edge computing, there are obviously challenges to navigate, and some of these challenges are similar to what we, at least at a higher level, are similar to what we face in a cloud computing environment. I have highlighted three key areas here: security, edge data management, and infrastructure management and orchestration. From a security standpoint, I think the biggest challenge is around authentication and trust management. Each time an edge node connects to an aggregation node, a mutual relationship of trust has to be established, and that too at a machine speed. And this challenge even becomes more grave in a virtualized environment with large number of edge nodes, which are even software defined. So what this really means is that some novel approaches are really needed to define how edge nodes are going to connect with aggregation nodes each time without really impacting the latency, because that's the key driver for anybody to move towards edge computing. The second critical challenge is around edge data management. Like I said earlier, that roughly about 80% of data even today is actually stored on client devices or M2M modules. It becomes imperative to ensure that there is no data loss, data integrity and privacy are preserved. And to accomplish this feat, organizations really need to ensure that no confidential data actually gets duplicated, copied, or synced to a third-party cloud location without proper authorization. This is also important in view of evolving data compliance regulations. Like we know, almost all the data compliance regulations are actually focused on transfer and access of personal data. So it becomes very important for enterprises to really have a complete control over the flow and residency of data, which basically means they need to have a end-to-end view where their data is stored and from where it is flowing to what storage location. Another aspect which is important with respect to edge data management is data tiering, which is essentially the question that how do one decides which data is going to reside at edge tier or edge cloud, and what data will get pushed to a centralized cloud. And this is not simply a question of what's really needed in real time and what is not really needed in real time. There could be other factors that need to be considered, specifically the cost of data storage, as well as the long-term value of the data. Lastly, the challenge which I want to talk about is the management and orchestration of infrastructure. In an edge computing environment, this really becomes challenging given some of the unique characteristics, such as frequently on the move client. So you can think of an autonomous car or self-driving car, right, which will keep moving, and as it's going from point 1 to point 2, it will really need to connect to the edge cloud at different cellular base stations. The other aspect here is the heterogeneity of access technologies, because today, in today's hyper-connected world, we have variety of intelligent endpoints, all of which might use different technologies like 4G, 5G, WiMAX to connect with the edge cloud. So in such a heterogeneous environment and fluid environment, how does really one ensure that the infrastructure, the edge infrastructure is really available and resilient? What markets believe is like any other technology, what will happen is, of course, I mean, some novel approaches will emerge to address these challenges. And vendor innovation is really going to be key to address these challenges. In fact, one such innovation is FileFlex, which is around edge data management, which Tom is going to talk about. So I'll hand over the presentation to Tom.
Okay, great. Thank you very much, Vivek. That was excellent. So what I'm going to talk about here is talking about how you can use that edge technology. It's an emerging type of a cloud technology to address the privacy, security, and productivity issues that are particular to traditional cloud sync and share, and put all of it under IT control. So we're going to take that technology and show you how you can apply to this particular vertical application of file sync and share. And what I'll do is I'll talk about how the centralized architecture of the cloud is today, so you can understand where we are today and then where we think it's going to go, how it can be applied to edge technology. And then I'll introduce our solution, which is called FileFlex. And FileFlex is a solution that uses edge technology to provide that cloud functionality of remote access, sharing, and collaboration to the entire storage structure of an organization, and put all of it under IT control. Breakthrough solution, we were recently recognized by Red Herring and awarded their Global 100 Disruptive Technology Innovation Award. So we don't have any time to waste, so I thought we'll waste some time. So what I want to do, I'm going to do something I've never done before, and I'm going to try and have us play a live Kahoot. Okay, I don't know if you guys are familiar with Kahoot, but I want everybody right now to take out their cell phones. Everybody on the call, take out your cell phones and go to kahoot.it. So take out your cell phone, go to kahoot.it, and I'm going to just switch off my screen here over to the Kahoot. I'm going to launch it. And I'm going to explain what a Kahoot is. Okay, and you're going to get a pin here in a second. So you go to kahoot.it on your cell phones and put in this pin. And we're going to play it together over a webinar. And we're all over the world. We're going to play it together. I've done this in front of a live audience, but I've never done this over a webinar before. So we'll see how it goes. And what Kahoot is I'm going to ask you a question. Everybody in the audience, I'm going to ask a question. And then from the question, you're going to guess an answer, and you're going to answer it on your cell phone by picking the right answer on your cell phone. And then you'll get points depending upon whether you get the right answer or not. And you'll get points depending on how fast you can answer the question. And we can see here who can come in and win the contest here. I don't have a prize for you, unfortunately, because it's over the internet. In a live audience, I give a prize out. Sorry, we can't do that here. So give it a couple seconds here. Everybody log in. Kahoot.it. Pick out your cell phone, please. Go to Kahoot.it. And okay. And we're going to just let people log in here. It might take you a couple seconds because you've not done this before. Okay. Okay, let's see how we go here. Okay, I'm going to start. I'm going to ask the question. I'm going to read out the answers. You're going to pick the the correct answer on your phone and click the button on your phone for the correct answer. Okay, so here we go. According to Marcus and Marcus, the business cloud market was $3.3 billion in 2018. How large will it be by 2023? Red is $6.6 billion, blue is $7.5 billion, yellow is $9.9 billion, and green is $10.9 billion. So red is 6.6, blue is 7.5, yellow 9.9. There we go. So two of you we got Dixie got the right answer, the fastest, followed by B. So there we go. That's the first one. Now, the reason that the market is growing, it's exploding. The market's already huge, and it's exploding. And the reason for that is because we have a remote workplace, and we have the digital workplace, and people want to be able to work from their homes. They want to be able to work from their traveling, and able to have the right tools to do that. You have to be able to access all your business information. And so the cloud is one of the major tools for doing that, and it's exploding in that regard. Okay, I'm going to go to the next question. Here we go. According to Markets and Markets, which segment of the business cloud market is expected to grow the fastest? Red is public cloud, blue is EFSS cloud on-premise, yellow is private cloud, and green is hybrid cloud. If you guys understand the differences in the clouds, but red is public, and there we go. The hybrid cloud is the correct answer. And the reason for that, see how our score is. Dixie's, again, #1, commanding lead here now. The reason is because when you put things in the public cloud, you're putting things on other people's computers. If it's a Microsoft or Google, you're putting and some of that's confidential. So what people do is they say, okay, I'm going to put some of my information on the public cloud, but some of it I'm going to build my own private cloud, host it myself, and put my confidential information there. And that's why, but that's expensive. So you can't put everything there. So you use a combination of the two. And that's why hybrid clouds are exploding as the fastest growing segment, because people have to protect confidential information. Next question. What percentage of organizations store confidential information in a public cloud? 27% public cloud is red, blue is 52%, yellow is 75.4%, and green is 83%. What percentage store information in public cloud? And the correct answer was 83%. Okay, Dixie's catching up. Dixie's catching up here. Okay, we got one more question. This is our final question. And by the way, the reason we put confidential information in the cloud is the same as a hybrid cloud is in a way, is because building your own private cloud to protect confidential information is very technical and it's very expensive, and only the largest companies can do it. So we put it in a public cloud. We make the compromises. We pretend that nobody cares, and it's all okay. But we do it anyways, even though we know we probably shouldn't be doing that for the confidential stuff. Okay, last question. Here we go. What percentage of workloads are still deployed on-premise? 25% on-premise is red, blue is 50%, yellow is 80%, and green is 90%. How much is still on-premise? And the answer is 80%. So it's the same thing. Fun. Oh, you just narrowly won. 1925 points. And everybody got 2 out of 4 questions. It was the fun got them the quickest. Yeah, so we put things on premise. So we still have about 80% of workloads are not in the cloud. Even though 95% of companies use the cloud, 80% of the workload is not in the cloud. So wouldn't it be nice to have some kind of a tool and some kind of a technology that could address that 80% of the on-premise? Well, that's the promise of edge technology. So let me show you that now. So this is the chart that shows the growth of the business cloud market and how it's growing from 3.3 billion in 2018 to 10.9 billion. So it's growing explosively. Again, it's that digital workplace, remote workers, we're driving the need for the business cloud market. And the fastest growing segment at 30.5% is the hybrid cloud, simply because private clouds are very expensive and technical to build. So you can't use it for everything. Here's your architecture that we use for a connected world. It works great. And what it does is it shows you could have hundreds or even thousands of devices syncing part of their memory to a central server cluster. And then you have thousands of users all accessing that data that's on the central server. So it's a centralized cloud computing model. And you can see that we do all that over the internet, and that server, it could be located on premise, it could be located on a third party. If it's with a third party, as most of them are, then that third party will have backups, and may have redundant locations for faster access around the world. And if you're hosting it yourself, that's called a private cloud. If it's with a third party, it's called a public cloud. There's an enterprise version of a public cloud which allows IT to control the users. That's called Enterprise File Sync and Share, or EFSS. Okay, that's the architecture we have today, and there's some issues with that we would just tend to ignore them or overlook them. And one is that you're syncing and duplicating. If it's to a public cloud, you're syncing and duplicating to somebody else's computers. But in all cases, you're increasing your threat surface because you're making a copy. You're either giving it to a third party or you're putting it on a secondary location. And that copy also have a nearline backup and an offline backup and maybe redundant locations. And that makes for a more complex storage structure. When you have an increased threat surface, more complicated storage structure, that increases your risk posture just by default. The other thing is this is very resource dependent. You have all these devices syncing to the server has to sync with them. They're all constantly communicating with each other. It's very resource intensive. The other thing, it applies only to a subset of data. So if you have, let's say, 1,000 terabytes in your of data in your company, and you have 100 terabytes of cloud, then you have 90 terabytes that's not accessible from the cloud. Only 10 is, and even 10 is a huge cloud storage that you might have, 10 terabytes, but it's only a subset of data. So you're always managing that. Your sync folders get full. You end up buying more storage than you really thought you needed, or you're deleting stuff and you're swapping it back and forth. And often data that you want may not be accessible when you need it because you have to juggle those subsets all the time. And it's expensive. You know, if it's a data center, you have to build a big expensive data center. Somebody's got to build it and pay for it, and those are expensive to build. And then if you're on with a third party, there are very inherent privacy issues. Okay, see, from a privacy perspective, you never want to be putting your confidential information on the server of someone else's server, someone else's computer. Like you don't want to be putting your confidential information on a server owned by an Amazon or Google or Microsoft if it's confidential, because that data can be accessed. So we're under the impression that privacy is protected by data residency. In other words, that data is in the residency, is the server is located in the geographic boundaries of your country, but it's not necessarily true anymore. It's not true at all, because that data can be, Phil, you're showing up on my screen there. The data can be accessed in secret by the cloud provider. They're required by law to access that information, make sure you're not using it for illegal activities, such as copyright infringement or anything else that might be breaking the law. It's accessible by law enforcement of your local country, and with the Cloud Act in the US, it's accessible by foreign powers, and other countries are passing similar laws that allow them access to cloud storage no matter where it's located, even if it's not within their geographic boundaries. Now, this is the architecture of a decentralized cloud or an edge computing model. This is the architecture being driven by IoT and 5G, as Vivek explained, and it's the architecture going forward into a hyper-connected world. And what that does is it sees our central cloud being used as a switchboard. And what it does is allows for direct connections between the storage and the users, or between the devices and the users, or between devices and devices. And so nothing is stored in that central server. The server acts like a switchboard. It also acts like a policeman enforcing policies. With an edge architecture like this, of the hyper-connected world, privacy is protected by keeping the data on premise. You're never giving it to a third party. It's always behind your corporate firewall. It's on your corporate storage assets. It's in specific geographic locations that you can control, and it's all access control with users that you want to be able to access it. So with this access, with this technology, it totally eliminates any kind of secret data exfiltration that is available in a public cloud. It protects your privacy. You can access all the storage. Everything in the edge can now be accessed, not just subsets, because there's no centralized limitations on what that central server can hold. The server just acts as a switchboard, and it leverages your existing investments, so it's the lowest cost model. We know that 95% of corporations out there use the cloud in some capacities, but only 20% of your workloads are deployed in the cloud. So 80% of the workloads are still on-premise. They may not be accessible or from the cloud when you need them. And it would be great to have a tool that would allow your digital workforce and your remote workforce to also use that have access to the 80%. Now you ask people, why do they buy cloud storage? Why do the users, why do organizations buy cloud storage? And here's the answers that was from a survey from Best Storage Products in 2016. Okay, 52% said collaboration is number one. 45% said file sharing and security, then remote access and simple access, and centralized and IT management. Okay, so those are your main reasons why you want cloud storage, and that makes sense. We're trying to enable a remote workforce. Does anybody on here, it's kind of a rhetorical question because you can't answer me, but does anybody here notice what's not on the list for buying cloud storage? What's a reason that's not on the list for buying cloud storage? And I'll tell you. The reason is storage. Nobody buys cloud storage because they need more storage. We got lots of storage. People need accessible storage, not storage. They need accessible storage. And that's why they're buying cloud. They want the tools, they want the collaboration, the file sharing, the remote access. Okay, that's what they want, those productivity tools. They don't need storage. And that's what's going to lead us to FileFlex, and that's what this edge technology solution can provide for you. What FileFlex does is it's a service that provides that cloud storage functionality to your entire company-owned infrastructure and puts all of it under IT control. Because we use the edge technology, we offset the high cost of a centralized cloud, we increase the security threshold of current cloud-based solutions, and it creates an intelligent global network of enterprise content of the entire organization. It can all be accessed from a single dashboard because we can access all the devices using the cloud technology. So we would turn your entire corporate infrastructure into a virtual cloud. We provide that cloud functionality, remote access, sharing, and collaboration to everything in the company. We put all of it under IT control, and we have the option of security hardening additionally at the chip level by Intel SGX technology, and I'll get into that in just a moment. All your data remains in its original locations. You access the data from their source locations. Nothing is copied to a third party or a secondary location. And because of that, organizations can keep control of their data. It's a software solution that's applied to your existing storage, all managed by your own IT department. There's no need to build an expensive data center or rent out an expensive data center. You don't have to subscribe to an expensive EFSS service. And because of that, it's significantly cheaper than existing cloud solutions. It's very easy. It's very quick to set up. Requires almost no management once it has been set up. And we have a solution which has an option to further harden it at the chip level with Intel SGX technology. And what that does is we can, when all the communications are encrypted, of course, but we can actually generate the encryption keys inside the secure enclaves of the chip itself, the Intel chips, so that it's protected against snooping and intercept, even on systems that are compromised by malware. The malware can't get into the SGX enclaves. They can be in the memory kernel, which means you may have worse problems than snooping and intercept, but no one else in the world can do this. No one else can give you that secure end-to-end encryption where the encryption keys are generated inside the secure enclaves of the chip, giving you a silicon-to-silicon level of data protection. We've done this in close relationship with Intel. as our partner in this. And I'm going to let this spokesman from Intel tell you a little bit more about it from their point of view. Okay, this is a video, just a short little segment of video we made for the Intel sales force so they would know how to sell this solution. But this is just a quick little portion of that training video for the Intel salespeople. So here we go.
This is Jim Gordon, General Manager of Client and Data Center Security Platforms at Intel, and we are pleased with Qnext as they bring their innovative FileFlex enterprise solution to market. FileFlex is a hardened silicon-to-silicon remote access, sharing, and collaboration solution that is enabled by Intel vPro technology. Employees need to share files and organizations need to secure their data. Compatible with Intel's latest 8th generation vPro technology, Qnext FileFlex enterprise solution uses secure enclaves to provide added protection below the application layer, below the OS layer, and below the BIOS. This enables secure file sharing at the deepest level within the silicon itself, ensuring that shared data is not snooped or tampered with at any stage of access or transmission. And as data is the value of any business, protecting it with innovative security solutions is crucial. Please visit our website to learn more about security solutions with Intel.
Okay, great. So that was Jim Gordon from Intel. Now, from a productivity point of view, because there's no duplication of files, there's no syncing, and you're accessing, sharing, and working from files from their source locations, not from a centralized server. There's no complicated management needed in order to keep track of the files, and everybody's working from the same document. But also, so that's going to improve your productivity. But also with that, everybody, let's say you're collaborating with 100 people in an office and 10 people are remote. That means that 90 people in the office have to be uploading and downloading to the cloud their documents so those 10 people in remote can get them. With every version, every single edit or change have to be uploaded and downloaded and synced to the cloud. And the clouds have tools to make that better, like syncing tools to do that. But if you have large files like AutoCAD files, that can be a real pain. With a decentralized cloud, only the remote employees need to upload and download. Everybody in the office just works on the centralized shared network drive. And so the productivity gains and the benefits from that are enormous. I'm going to just open up a calculator that I wrote here. So here's a productivity calculator. Let's say you've gotten the 90 people in the office, and you can plug in your own numbers and your own assumptions on this, but you're paying them $65,000 a year. And let's say they're using large files like AutoCAD files. So they're spending about an hour a week, 1 hour a week uploading files to the cloud and half an hour downloading and another 15 minutes producing links, okay, and sharing links and putting them into their emails. So, you know, that's costing you about $6,400 in lost productivity a year for those 90, per employee, sorry, $6,400 per employee. So for FileFlex, it costs you $10 per user per month. For $120 a year, you're gaining $6,400 in productivity gains. Now let's say that, okay, it's just for general business, okay? We're gonna just lower that to 6 minutes. And at 6 minutes, uploading and 6 minutes downloading, 6 minutes creating links a week in productivity gains and time saved, you're still saving $1,100 in productivity gains for $120 a year spend. So spend $120, gain $1,100 in productivity gains. So the productivity gains just by itself are very, very significant. So it's a great solution for solving customer problems. Whether if you're security conscious, it's ideal for security conscious clientele. Anybody in health services need to protect personal health information and meet HIPAA requirements is perfect for you. Architecture firms deal with large files such as AutoCAD design projects. It's pretty much, there aren't any good solutions for you guys except moving to an edge solution like this. Banking and financial, there's a lot of regulations and whatnot. This particular customer, they were sending confidential files around by courier on a USB stick because they're in a regulated environment. They're not allowed to use the cloud in their country. Law firms have to protect client attorney privilege and adhere to the standards of their professional associations. It's perfect for them. High-rise construction is another one because it allows for collaboration, on-site access from engineers, architects, project managers, skilled workers. You know, they have to work in their offices, but they're often very remote. We have a number of high-rise and construction companies using the product. Highly regulated companies. This one here is a publicly traded company. They deal with publicly traded ETFs and very regulated, and they have to protect personal identifiable information and confidentiality of their documents. Hospitals, perfect for hospitals. This one here is already using it with their legal and research department. Actually, they're rolling it out to the whole hospital right now. Pharmacy, this is a small retail chain of pharmacy stores, but they have to do collaboration and file sharing between their head office and remote pharmacists while protecting personal health information. This one here, next one down, is an outdoor advertising agency. They deal with large media libraries and collaboration of huge Adobe After Effects, InDesign, Illustrator, Photoshop files. And the last one I put on here is the military. This is a Navy in South America, and they have to have an inexpensive way of accessing secure access to an Oracle database and file sharing and collaboration. They're actually just finished their pilot. We're in the RFP right now, and they're going to also look at putting it in their Army, and a number of other militaries in South America are already looking at going into pilots now as well, because it's our same partners dealing with all of them. So it's perfect for solving customer problems. And what I want to do is, I'm basically finished here now. I'm going to conclusion. We're going to use that edge cloud with FileFlex for access, sharing, and collaboration. It ensures data privacy. There's no duplication, no third parties, no secondary locations. Your data stays in its source locations behind the firewall and corporate-owned assets. It's a software-only solution that you can simply add very, very easily to your own organization. It's the lowest cost model because of that. You don't have to build a data center. You don't have to have a lot of technical expertise. And it gives you the strong productivity gains. So with that, I'm going to conclude. I'm going to hand it back to you, Phil, but I'm going to say someone from our organization, we have the names of people on the call here today, and we're going to contact you to see if you're interested in a demo of FileFlex. I think Bernadette will be the one who will call you and try to arrange a demo with you. So with that, I'll turn it back over to you, Phil, okay? And thank you very much for letting me speak to everybody.
Hey guys.
There we are.
Thanks, Tom. That's really great. I'd like to thank everyone for attending. If you haven't already, I'd love you to join our LinkedIn group. We just launched our website, and you'll see a bunch of articles and opinions on the ECA site. You can certainly contribute, and we can take a look and publish them. Love to have lots more opinions. Become a member there as well. And we have a very exciting webinar next month, so you can stay tuned on that. In terms of questions, if you have any questions, you can either put them here or send them to us, and we'll be sending out answers to the questions over the next 2 or 3 days. So thank you all for attending, and appreciate you coming to the first ECA webinar. Thank you.